Hello friends, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This video is part 1 on the chapter of properties of triangles. So this is the first video on the chapter of properties of triangles where I will discuss all the concepts that you have already studied in your previous class, that is class 6. So this video will be a preview of earlier class where I will discuss about the vertices, sides, angles of a triangle, and the side and angle properties of a triangle and the types of different types of triangles. And finally, I will solve the problems of exercise 15A from the textbook of author R.S. Aggarwal. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author R.S. Aggarwal. And if you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I highly suggest and request that you please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my notes prepared, rough notes prepared on the left hand side, and on the bottom left corner you will see I have the scanned copy of the problems from exercise 15A from the textbook of author R.S. Aggarwal, and on the right hand side on the canvas I will discuss all the concepts that of this video, and we'll solve the problems from exercise 15A. So the concepts of triangles or the properties of triangles that you have already learned in your previous class is that what is a triangle? A triangle is formed by three non-collinear points. So a triangle ABC is formed by three non-collinear points ABC. That is, they do not lie on the same line. They lie on different lines. They do not lie on the same line. Such 3 points can form a triangle. If the three non-collinear points are ABC, then we can form a triangle ABC where we will have now a triangle has three vertices. If the points are non-collinear points are ABC, we will have vertices A, B, and C, and also we will have three sides. Three sides in the figure you can see in the triangle ABC. Now a triangle ABC is denoted by the symbol of this small triangle. This is the symbol for denoting a triangle. So now if we write ABC, this means that this is one second I will okay. So this means this is the triangle ABC. Okay. So we have now in the triangle, in the figure on the left hand side, you see a triangle ABC. So a triangle has three vertices A, B, and C, and it has three sides. The sides are AB, BC, and CA. Now conventionally, the side opposite to the vertex A is known as BC. The side opposite to the vertex B is known as AC, and the side opposite to the vertex C is named as AB. Now it also has three angles. As you can see, it forms three angles. The angle BAC is formed at the vertex A. So it is this angle is referred as angle A or angle BAC. In short, the angle BAC is referred as angle A since it is formed at the vertex A. Similarly, the angle CBA or angle ABC is formed at the vertex B. So it is also known as the angle B. And the angle BCA is formed at the vertex C, so it is known as the angle C. So we have angle A, B, and C from the named after the vertices of the triangle. So this is very basics of what a triangle is. A triangle is formed from three non-collinear points ABC, and we have three sides and we have three angles. Now what is the perimeter of a triangle? A perimeter of a triangle is the length. Now each side has a length, and each side of a triangle has length, and all the lengths of the sides are greater than 0, and also all the angles formed, that is angle ABC, they are all greater than 0. There are none of the angles or none of the sides is 0. What is perimeter of a triangle? Perimeter of a triangle is the sum of the lengths of the sides. So perimeter of a triangle is AB plus BC plus CA, where we conventionally use AB as the since AB is the name of the side AB, we can also use it without any issue as the length of the side AB. Similarly, BC is the length of the side BC and CA is the length of the side CA. So the perimeter of the triangle ABC is AB plus BC plus CA. And also, a very important fact about a triangle is that the sum of all the angles of a triangle is 180 degree. So angle A plus angle B plus angle C will be equal to 180 degree. Okay. Now, so a triangle ABC has 6 elements, that is the 3 sides AB, BC and CA, and 3 angles, angle ABC, angle BAC and angle BCA, or in short we say angle A, B and C. Okay, now let's discuss the types of triangles. We categorize the types of triangles based on 2 things. One is based on the length of the sides, and another one we categorize the triangle as based on the type of angles of the triangle. Now, the types of triangles based on the length of the sides there are 3 types of such triangles. The first one is the equilateral triangle. Now, an equilateral triangle, the length of all the sides are equal. So we have AB equals to BC equals to CA. Now, also, an important thing to note about an equilateral triangle is that all its angles are also equal. That is, angle A is equal to angle B is equal to angle C, and they each measure 60 degree. Since we know that since we know now why is each angle of an equilateral triangle equals to 60 degree. The first thing is that we know that angle A in the triangle ABC, in any triangle ABC, the angle A plus angle C, angle B plus angle C will be equal to 180 degree. Now, for an equilateral triangle, all the angles ABC are same. So we can say that we know that A equals to B equals to C. This is the definition of an equilateral. Sorry. All the angles will also be equal. Yes, if the triangle is equilateral, then all the sides of the triangle are equal. That is the definition of an equilateral triangle, and this also implies that all the angles of the triangle are also equal, and they will be equal to 60 degree, because the sum of the angles is equal to 180 degree. So this comes from the fact that if the angle A, B and C, they are all equal, we can say if each of those angles is x degree, then we can say that x plus x equals 180 degree. So this implies that 3x equals 180 degree. So this implies that x is equal to 60 degree. So for an equilateral triangle, the length of all the sides are equal, and also the angles are equal, and each of these equal angle measure 60 degree. Okay, that was equilateral triangle. Now, isosceles triangle. In an isosceles triangle, we have 2 sides equal. Two sides will be equal, and the third side will be some different length. Now, if we assume that the sides AB and AC are equal, so in the figure you can see we have AB equals to AC. These are the 2 equal sides, and if so, then in an isosceles triangle, another important property is that the angles opposite to the equal sides are also equal. So the angle opposite to the side AB is C, and the angle opposite to the side AC is B. So angle B will be equal to angle C. This is for the case when the sides AB and AC are equal. So length of 2 sides will be equal, and the angle opposite to those equal sides will also be equal. This is isosceles triangle. Now scalene triangle, in scalene triangle, all the length of all the three sides will be different. That is, the sides are of in unequal length. And also from this, it is this also implies that no all the angles of the scalene triangle will also be unequal. That is, no two angles are equal. So we have AB not equals to BC and BC not equals to AC. This also implies that AB not equals to AC. And of course, none of the angles are equal. No two angles are equal. So we have angle A not equals to angle B not equals to angle C, and angle A not equals to angle C. That is, all the angles are of different measures. So that was different types of triangles based on the length of the sides. We have equilateral triangle, isosceles triangle, and scalene triangle. Now types of triangles based on the angles. The first one is acute triangle. Acute triangle is a triangle where all the angles are acute angle. All three angles of the triangle are acute. Now acute means less than 90 degree. So we have in a triangle ABC, if it is an acute angle, if it is an acute triangle, angle A and angle B and angle C, all of them will be less than 90 degree. So that is all about an acute triangle. Now we have a right triangle. A right triangle is a triangle where one angle is a right angle, that is 90 degree. Now one thing to note is that in a triangle only one angle can be right angle. No two angles in a triangle, more than one angle cannot be right angle, or more than one angle cannot be 90 degree. Why? Because we know that the sum of the angles of the triangle is 180 degree, and if two angle becomes right angle, then their sum becomes 180 degree, and this will imply that the third angle has to be 0, and we know that in a triangle all the angles are greater than 0. So this is the reason in any triangle there cannot be more than one right angle. So in a right triangle we have one angle is right angle, that is 90 degree, and another thing to note is that the other two angles which are not right angle, the other two angles has to be acute angle, and their sum is 90 degree. That is, the other angles are complementary to each other. So if in a triangle ABC, B is the right angle, angle B is the right angle, then we have angle A and angle C. They must be acute angle, and their sum must be equal to 90 degree, because we know that the sum of all angle is 90 degree, and if one angle is 90 degree, then obviously the sum of other two angles has to be 90 degree. So if in a triangle ABC, B is the right angle, then the sum of angle A and angle C has to be 90 degree. Okay, so that was right triangle. The third one is the obtuse triangle. In an obtuse triangle, one angle is an obtuse angle. And what is an obtuse angle? An obtuse angle is an angle which is greater than 90 degree but less than 180 degree. Also, in any triangle, only one angle can be obtuse. No more than two angles cannot be obtuse, because if two angles are obtuse, then the sum of their angles, sum of those angles will become greater than 180 degree, and we know that the sum of the angles of any triangle is always 180 degree. So an obtuse triangle is a triangle where only one angle is obtuse, and also we know that in a triangle only one angle can be obtuse. In a triangle, two angles cannot be obtuse. So that was obtuse triangle. So that is all. These are all concepts that you might have already studied in your previous class. I just wanted to make a video to recall what you have learned in your previous class and do some problems from exercise 15A. So I hope these concepts are clear. I mean, these are very, very simple concepts. You just need to know them. And just for the types of triangles, you need to know what are the basic definition of the types of triangles and their properties. Okay. Now let's try to solve the problems from exercise 15A. Okay, so problem number 1 says in a triangle ABC, it is given that in a triangle ABC, angle A is equal to 72 degree and angle B is equal to 63 degree, and it is asking the angle, find angle C. So we know that angle A plus angle B plus angle C is equal to 180 degree. That is the sum of all the three angles of a triangle is 180 degree. Now angle A is given to be 72 degree, angle B is given to be 63 degree. So we have 72 degree plus 63 degree plus angle C equals to 180 degree. This implies 72 plus 63 is 135 degree plus angle C equals 180 degree. So this implies angle C equals 180 degree minus 135 degree. This is equal to 45 degree. So angle C is 45 degree. Okay, let's do problem number 2. It is given that in a triangle DEF, angle E is equal to 105 and angle F is given to be 40 degree. Then what will be the angle D? Okay, we know that in the triangle DEF, the angles are DEF, and the sum is equal to 180 degree. Now, so this is angle D plus angle E is given to be 105 degree and angle F is given to be 40 degree. So we have angle D plus 105 plus 40 equals to 180 degree. This implies angle D plus 145 degree equals 180 degree. So this implies angle D equals 180 degree minus 145 degree. This is equal to 35 degree. So angle D is 35 degree. Okay. I will not do, okay, let me do it. I mean, problem 1, 2 and 3 are similar types of problems. They are exact same type of problem. But anyway, do it. Let's do it. We have triangle XYZ. It is given that angle X equals 90 degree and angle Z is given to be 48 degree. Then it is asking to find angle Y. We know that angle X plus angle Y plus angle Z is equal to 180 degree. So this implies angle X is given to be 90 degree, angle Y we have to find, and angle Z is given to be 48 degree. This is equal to 180 degree. Now this implies angle Y plus 90 plus 48 degree is 138 degree equals 180 degree. Now this implies angle Y is equal to 180 degree minus 138 degree. This is equal to 42 degree. So angle Y is 42 degree. Okay. So while I am solving the problem, you can pause the video and take a screenshot of the solution if you think the solution will help you. Okay. Let's solve problem number 4. Find the angles of a triangle which are in the ratio 4:3:2. Okay. So in this kind of problem, we know to solve this problem, you will need to have the concept of ratio and proportion. That is, we know that the sum of the angles, the concept of ratio that we will need is that ratio and proportion. If three quantities are given, the ratio of three quantities are given, and also the sum of those three quantities are given, we can find the individual quantity by using a straight cut formula. I have already covered a lot of videos on the chapter ratio and proportion. If you have not watched them, and you can see this, you can find all the videos on the chapter ratio and proportion in the same playlist. So let the angles be the standard way of solving the this kind of problem and ratio and proportion is that when the ratio is given and we also know the sum of the quantities is also given, we assume the quantities to be all the quantities to be a multiple of x, that is based on the terms of the ratio. We assume each quantity to be the terms multiplied by some x, where x will be some number, non-zero number that we will have to find out. So let the angles be 4x, 3x and 2x, since the ratio of the angle is given to be 4:3:2. So let the angles be 4x, 3x and 2x. Now from the properties of the triangle, by the way, the sum of the property that the sum of the angles of a triangle is 180 degree, this is known as the sum of angle property. So we will have 4x plus 3x plus 2x equals to 180 degree. This implies 9x is equal to 180 degree. This implies x is equal to 20 degree. This implies angles are 4x, that is 4 into 20 degree, comma 3 into 20 degree, comma x, that is 20 degree. This is equal to 80 degree, 60 degree and 20 degree. These are the angles of the triangle. Okay. Let's do problem number 5. It says one of the acute angles of a right triangle is 36 degree. Find the other. So we have a right triangle. Let's say the triangle be A, B, C, and let B be the right angle. So find the angles of a triangle. One of the acute angles of a triangle is right triangle is 36 degree. Find the other. So if in the let's say the triangle is ABC and the angle B is right angle. We know that angle A and angle C are acute angles. So we know that angle A plus angle C will be equal to 90 degree. Also let that it is given that angle one of the acute angle is 36 degree. So let A equals to 36 degree. This implies 36 degree plus angle C equals 90 degree. This implies angle C equals 90 degree minus 36 degree. This is 54 degree. So the other acute angle is 54 degree. Okay. Let's do problem number 6. Problem number 6 says the acute angles of a right triangle are in the ratio 2:1. Find each of these angles. Now, okay. So we know that, let's say, you can refer the figure from problem number 5. We have, it is given that the ratio, the acute angles of a right triangle are in the ratio 2:1. So let's say we have, it is given that angle A is to angle C is equal to 2:1. Okay. So let's assume that angle A is equal to 2x and angle C is equal to x. This implies that we know that the sum of the acute angles of a right triangle is 90 degree. So this implies angle A is 2x and angle C is x. This is 90 degree. This implies 3x equals 90 degree. This implies x equals 30 degree. So angle A will be 2 into 30 degree, that is 60 degree, and angle C will be x equals to 30 degree. So 60 degree and 30 degree are the acute angles of the right triangle, where it was given that the ratio of the acute angles is 2:1. Okay. Let's solve question number 7. It is said that one of the angles of a triangle is 100 degree and the other two angles are equal. Find each of the equal angles. So let in triangle ABC, let angle A is equal to 100 degree and let angle B is equal to angle C. Let's say they are equal to x. We are assuming the angle B and C to be equal, and let's assume that angle B and C are equal and they are x. So from the fact that angle A plus angle B plus angle C equals to 180 degree, we know this. This implies angle A is 100 degree, angle B is x, angle C is x. This we have 180 degree. So we have 100 degree plus 2x equals 180 degree. This implies 2x equals 180 degree minus 100 degree, that is 80 degree. This implies x equals 40 degree. Therefore, we have angle B equals to angle C equals to 40 degree. Okay. Let's do problem number 8. It says each of the two equal angles of an isosceles triangle is twice the third angle. Find the angles of the triangle. So it's an isosceles triangle. Let's say the isosceles triangle is like this. We can always roughly assume the triangle to be like this, A, B, and C. So let AB equals to AC. If each of the two equal angles of an isosceles triangle is twice the third angle. So this implies if AB equals to AC, we assume, then we will have angle B, the two equal angles will be angle B and C. It is also given that the each of the two equal angles of an isosceles triangle is twice the third angle. So this is equal to, the third angle is A, is twice angle A. Now we know that angle A plus angle B plus angle C is equal to 180 degree. So this implies angle A plus B is equal to twice A. So we have twice A. C is also equal to twice A. We have twice A equals to 180 degree. This implies 5A, 5 times angle A is equal to 180 degree. This implies angle A is equal to 180 degree by 5. This is 36 degree. So this implies angle B is equal to angle C is equal to twice of angle A, that is 72 degree. Okay. Let's do problem number 9. Problem number 9 says that if one angle of a triangle is equal to the sum of the other two, show that the triangle is right angled. Okay. In triangle ABC, let it is given that one angle of a triangle is equal to if one angle of a triangle is equal to the sum of the other two, let angle A is equal to angle B plus C. You can consider anything. You could have also considered angle B equals to angle A plus C, or angle C is equal to A plus B. It will make no difference, and it will make no difference. You can always assume one angle to be any angle to be the sum of the other two angles. So I am assuming that angle A is equal to angle B plus C. Now we know that angle A plus angle B plus angle C is equal to 180 degree. Now this implies that angle A, now angle B plus C is angle B plus C, we have assumed to be angle A. So we have angle A plus angle A is equal to 180 degree. This implies twice of angle A is equal to 180 degree. This implies angle A is equal to 90 degree. So we have found that angle A is 90 degree, and hence the triangle is a right angle triangle, right triangle. Okay. Let's do problem number 10. Problem number 10, it is given that in a triangle ABC, it is given that angle twice of angle A is equal to thrice of angle B, and this is equal to 6 times angle C. That is, twice of angle A is equal to 3 times angle B is equal to 6 times angle C. So here also we will use the concept of ratio and proportion. Now, if we consider the angle ABC as quantities, it is clearly, and when these kind of equations or relations are given, that angle A twice of angle A is equal to thrice of angle B, this is equal to 6 times angle C, we can clearly find the ratio between the angles AB and C. Now, how? We know that twice of angle A is equal to twice of angle B. This implies we can say that angle A pi angle B is equal to 3 by 2. And also we have angle 3 times B is equal to 6 times angle C. So this implies angle B by angle C is equal to 6 by 3. Now over here we can say that angle A is to angle B is equal to 3 is to 2. And over here we can see that angle B, the ratio of angle B and C is equal to, this is equal to 2 by 1. So this is 2 is to 1. So we have the ratio of angle A is to B and angle B is to C. And since in both the ratio, the common term angle B, the term in the ratio of the common angle B is same 2, we can clearly say from these two ratios that angle A is to angle B is to angle C is equal to 3 is to 2 is to 1. Now that we know the ratio of the three angles, we can easily find the individual angles. Now we are, it is similar to the problem problem 4, where it was given that find the angles of a triangle which are in the ratio 4:3:2. And in this problem, problem number 10, we have found that the ratio of the angles ABC to be 3:2:1. Now, so let angle A be equal to 3x, angle B equal to 2x, and angle C equals to x. All these are in degrees. I'm omitting the degrees. I hope it is understood. Now, this implies that we know that angle A plus angle B plus angle C is equal to 180 degree. So this implies 3x plus 2x plus x equals to 180 degree. This implies 6x is equal to 180 degree. This implies x is equal to 30 degree. Therefore, angle A is equal to 3x, that is 3 into 30 degree, which is 90 degree. Angle B is equal to 2 into 30 degree, that is 60 degree. And angle C is equal to x, that is 30 degree. So 30 degree, 60 degree and 90 degree are the angles. Okay, let's do problem number 11. Problem number 11 says, what is the measure of each angle of an equilateral triangle? Okay, we have already discussed in the theoretical part that the angles of an equilateral triangles are equal, and each of those equal angle is equal to 60 degree. Now, why? Now, in equilateral, we know that in equilateral triangle ABC, angle A, all the angles are equal. Angle A is equal to angle B equals to angle C. Let's say the angle B x. So this implies that angle A, angle B plus angle C equals 180 degree. This implies that x plus x plus x equals 180 degree. This implies 3x equals 180 degree. This implies x equals 60 degree. So we have found that each angle A, B, and C, which we have assumed to be x, is 60 degree. This is for an equilateral triangle. Each angle of an equilateral triangle is 60 degree. And what is an equilateral triangle? An equilateral triangle is a triangle where all the sides, the length of all the sides of the triangle are equal. Okay. Let's do problem number 12. A figure is given. Let's draw the figure first. We have a triangle ABC. We have a triangle ABC. And we have in the given figure, DE is parallel to BC. So we have a line. This is DE is parallel to BC. Okay. And if angle A is 65 degree, this is 65 degree, and angle B is 55 degree. Angle B is 55 degree. Find angle ADE, AED, and angle C. Okay. Now, a DE is parallel to DE. It is given that DE is parallel to BC. And of course, we can see that AC is a transversal. Now, here we will need the concept from the properties of parallel lines. I have already covered the chapter on properties of parallel lines in this same playlist. If you have not watched those videos, I highly suggest that you can watch the videos on properties of parallel lines. I think I have one video where I have discussed the properties and solved the exercise 14, and also there are two practice test papers that I solved, or maybe one. I'm not sure. Maybe one practice test paper. So we have DE parallel to BC, and we can clearly see that AC is a transversal which is intersecting the lines DE and EC BC at the points, distinct points E and C. So this implies that angle C is equal to angle DEA. It has found ADE. It has asked to find the angle ADE, okay, and AED. Okay. Now we have we know that since DE is parallel to BC and AC is a transversal intersecting the lines DE and BC, we will have angles ADE, AED equal to angle C, because they are corresponding angles. They are corresponding angles, or pair of corresponding angles. And now from the triangle ABC, in triangle ABC we have angle A plus angle B plus angle C equals to 180 degree. This implies angle A is given to be 65 degree, angle B is given to be 55 degree, plus angle C is equal to 180 degree. This implies 120 degree plus angle C equals 180 degree. This implies angle C is equal to 60 degree. So angle C is, we have found to be 60 degree. So this implies that angle AED is equal to angle C is equal to 60 degree. Now we have to find the angle ADE. So again see that DE is parallel to BC and AB is a transversal. AB is a transversal intersecting the parallel lines DE and BC at the point, distinct points B and D. So this implies that angle B will be equal to angle ADE, as they are corresponding angles. They are corresponding angles, and we know that corresponding angles are equal when the two lines which is being intersected by a transversal, they are parallel. So this implies that angle ADE is equal to 55 degree. So we have the three angle ADE is 55 degree, angle AED is 60 degree, and C is 60 degree. Okay, let's do problem number 13. Problem number 13 says, okay, so there are multiple parts. Can a triangle have, okay, can a triangle have two right angles? No, because two right angles, because if there are two right angles, the sum of the angles, sum of those two right angles will be 180 degree, and we know that the sum of three angles is 180 degree. So if two angles are right angles, the third angle has to be 0. Now in a triangle, no angle is 0. All angles in a triangle are greater than 0. That is the reason in a triangle there cannot be two right angles. Now, I'm not writing the reasons. Uh, Two obtuse angles. No, a triangle cannot have two obtuse angles, because if there are two obtuse angles, their sum will be greater than 180 degree, because an obtuse angle is greater than 90 degree. If an obtuse angle is greater than 90 degree, then the sum of two obtuse angles will be greater than 90 plus 90, 180 degree. And we know that the sum of three angles of a triangle is always equal to 180 degree. So a triangle cannot have two obtuse angles. So this is also no. 3. Two acute angles. Of course, a triangle can have two acute angles. If you see, if the triangle is the right triangle, then then we know that one angle is right angle, that is 90 degree, and the other two angles has to be acute angles, and their sum will be 90 degree. So triangle can always have two acute angles. So this is yes. 4. All angles more than 60 degree. All angles more than 60 degrees. No, it is not possible, because angle A plus angle B plus angle C, all angles more than 60 degree. No. So let's say in triangle ABC, let angle A be greater than 60 degree, angle B is also greater than 60 degree, and angle C is greater than 60 degree. Now we know this implies that angle A plus angle B plus angle C will be greater than 60 degree plus 60 degree plus 60 degree. This implies that angle A plus angle B plus angle C is greater than 90 degree. Not possible. This is not possible, because we know that in any triangle the sum of the angles is always 180 degree. So a triangle cannot have all the three angles greater than 60 degree. 5. All angles less than 60 degree. All angles less than 60 degree. This is also no, for the same reason. So in triangle ABC, let A less than 60 degree, angle B is also less than 60 degree, and angle C is also less than 60 degree. So this will imply that angle A plus angle B plus angle C will be less than 60 degree plus 60 degree plus 60 degree. This implies that this will imply angle A plus angle B plus angle C will be less than 180 degree, and this is also not possible, because the sum of angles of any triangle is always equal to 180 degree. Okay. 6. All angles equal to 60 degree. Yes, this is of course possible. Yes, for all equilateral triangles will have their angles equal, and each such angle will measure 60 degree. So this is of course possible. Let's solve problem number 14. Answer the following in yes or no. 1. Part 1. Can an isosceles triangle be right angle? Can an isosceles triangle be right triangle? Yes. Reason, let's say we can have A, we can have reason being we can have a triangle like this. A, this is a right triangle, an isosceles triangle where AB, we can have AB equals to BC. AB equals to BC means the angle, this will imply angle A is equal to angle C is equal to 45 degree, as we know that the sum of the other two acute angles in a right triangle is always equal to 90 degree. So we can have a triangle which is we can have a right triangle to be a an isosceles triangle to be a right triangle. That is by if the angle in an isosceles triangle, if we can always have the angle formed by the sides of the equal sides to be 90 degree, then it will be an isosceles triangle and also it will be a right triangle. Part 2 says, can a right triangle be a scalene triangle? Can a right triangle be a scalene triangle? Yes. What is a scalene triangle? A scalene triangle is a triangle where all the three sides have unequal length, have different length. All the three sides have different length. So of course, and we can always have a triangle which is a right triangle. So we can have something like this. Let's say we can always have something like this, where this is the angle, right angle. Let's say the triangle is ABC, angle B is 90 degree, and of course we know that angle A and angle C will be acute angles and their sum will be equal to 90 degree, but we can always have unequal angles A and C. Let's say, so we have angle B 90 degree and angle A, let's say we have 60 degree, and angle C we have 30 degree. We know that if all the angles are different in a triangle, it automatically implies that the triangle is a scalene triangle. That is, the length of the sides of the triangles are unequal. So we can always have a right triangle to be a scalene triangle, as the other two angles, the other two in a right triangle, the other two acute angles can be different, and if that is so, then it will obviously make the triangle a right triangle and also a scalene triangle, as all the sides will be unequal of a different length. Okay. Part 3. Can a right triangle be an equilateral triangle? Can a right triangle be an equilateral triangle? This is no. An equilateral triangle, equilateral triangle has all angles. Any equilateral triangle has all angles equal to 60 degree. So it cannot have an angle which is 90 degree. So a right triangle where one angle is 90 degree, it cannot have all the other two angles also 90 degree, because we know that a triangle can have at most one right angle. So this is no. 4. Can an obtuse triangle be an isosceles triangle? Can an obtuse triangle, but an obtuse triangle is a triangle where one angle is obtuse. Where one angle is obtuse, meaning it is greater than, an obtuse angle is an angle which is greater than 90 degree and less than 180 degree. So if we have, let's say, one obtuse angle, let's say this is an obtuse angle, let's say this is A, B and C. So the triangle formed is ABC, but this is obtuse. This is obtuse. There, the question is, can we have in such a triangle two sides equal? Because an isosceles triangle means two sides will be of equal length. Now, so if we make an obtuse angle, that is angle B, we can always have the length BC. We can always extend. We can always make the sides BC and AB equal. We can always create a triangle such that angle B is obtuse and the sides AB is equal to BC. And this will imply that the triangle is isosceles triangle. Okay. Let's do problem number 15. Now the question in the part 4 of the previous question number 14 part 4, we have to also and now an isosceles triangle means only two sides are equal. The third side will be of different length. Now we have to ensure that if one angle is obtuse angle, we are making the length of the sides AB is equal to BC, but we have to make sure that AC is not equal to AB. If AC is not equal to AB, then only we can say that it is an isosceles triangle, because in an isosceles triangle only two sides are of equal length. And can we ensure that AC is not equal to AB? Yes, I think so. If in an obtuse, if in a triangle, if the angle B is an obtuse angle, and if we make the sides AB and AC BC equal, then I think the side AC will always be greater than the side AB and BC. Okay, let's solve problem number 15. We have fill in the blanks. Right triangle cannot have an angle. A right triangle cannot have and what angle? We know that in a right triangle it cannot have another right angle or another obtuse angle. A right triangle cannot have it can have a right triangle. So it is saying what kind of angle it cannot have, a right triangle. Now right triangle, now what are the types of angles we know? We know acute angle, we know right angle, we know obtuse angle, we know reflex angle. Now reflex angles it cannot be, because reflex angle is more than 180 degree. So the choices are right angle, acute angle and obtuse angle. Now in a right angle it is asking it cannot have what kind of angle. Now in a right triangle it cannot have another right angle, it cannot have an obtuse angle, because in a right triangle the other two angles has to be acute, so it cannot have an obtuse angle. So the fill in the blanks will be obtuse. Part 2, the acute angles of a right triangle are. The acute angles of a right triangle. In a right triangle, we know that the other two angles are acute and their sum is 90 degree. So the acute angles of a right triangle are I think it should be complementary, because we know two angles are said to be complementary to each other if their sum is 90 degree, and we know that in a right triangle, other than the right angle, the other two angles are acute and their sum is always equal to 90 degree. Okay. Part 3, each acute angle of an isosceles right triangle measures, of course, 45 degree. Why? We know that in it is saying that each acute angle of an isosceles right triangle, meaning it will be, we know that in a, so the triangle will look like this, ABC, and let's say the angle B is 90 degree and AB, so this makes angle B is 90 degrees, so this makes the triangle a right triangle, and if we assume that AB equals to BC, it will become an isosceles triangle, and also this will imply that angle A is equal to angle C. Now also we know that angle A plus angle C has to be equal to 90 degree, as the sum of acute angles of a right triangle is always equal to 90 degree. So this will obviously imply, if we solve, that angle A plus angle C is equal to 90 degree, and so this will be angle A plus angle A equals to 90 degree. This will imply angle A is equal to 45 degree is equal to angle C. So each acute angle of an isosceles right triangle measures 45 degree. 4. Each angle of an equilateral triangle measures 60 degree, which we have already discussed earlier. Part 5. The side opposite the right angle of a right triangle is called hypotenuse. Hypotenuse. So this side is the hypotenuse. That is if the angle B is the right angle in a triangle, in a right triangle, if angle B is the right angle, then the side opposite to angle B is AC, that is known as the hypotenuse. And the sum of the lengths of the sides of a triangle is called perimeter. This is called perimeter. I hope we are okay. So this brings to the end of solving the problems of exercise 15A from the chapter Properties of Triangles. In the next video, I will move on to the next section of the chapter Properties of Triangles. I think I'm not sure what is the next topic. So tomorrow I will discuss the next topic on the chapter Properties of Triangles, and we'll solve the next exercise problems, that is 15B. And in the meantime, I will try to prepare another practice test paper, that is practice test paper number 2 on the chapter Properties of Parallel Lines, and will create a video to solve the practice test paper. That could come tomorrow or day after tomorrow. So I hope this video was beneficial to you, and if it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So that's all for this video. Until the next video, take care and bye.